So next question, question number 2. Determine the area of the shaded parts. Determine the area. I want you guys to do this question and tell me what you're getting as the answer. Determine the area of the shaded parts. I already have the drawing for you, so this is going to be very easy. It should be easier because you're not starting by getting the points of intersection and all that. So this is the shaded region. This point here is 2. This point here is -3. And then this curve here, this upper curve is y is equal to x squared plus 1. And then this lower curve is y is equal to 7 minus x. So the question is determine the area of the shaded part. And this is the shaded part. Note, I want this to be very clear. This part here does not get to the x-axis. As you can see that this part is not, there's some space. It doesn't get to the x-axis. So this is the x-axis, and this is our y-axis. You're being told to determine the area shaded. It means, first of all, I am going to get this area. Now I want to mark them, but I'll rub again. This curve right here, this y is equal to 7 minus x. If I am to integrate from this point to this point and integrate over this curve y is equal to 7, the area that I will be getting will be the whole of this. You see the area that I've shaded with red? That is, if I integrate from -3 to 2 of which curve? This curve which is above it, this one. That is 7 minus x dx. However, that is not the area that I want. So if I get that, I will get this area shaded plus this which was not shaded initially. Are we together? But I can be able to also get the area of this curve minus if I get the area that is bounded by this curve. You look at that curve, x squared plus 1, which area is it bounding? Let me shade it with a different color of marker pen. That curve right there is covering this area. So if I take the whole of the area, remove this one that I've shaded in blue, then I will be able to be left with the black one that I needed initially. I hope we are together, guys. So minus the one that I do not need, or the one that is shaded in blue, the interval is still, or the limit is still from -3 to 2. So we are integrating from -3 to 2. And what is the curve that is bounding this area? This is the curve, and it is y is equal to x squared plus 1. So x squared plus 1 dx. If we evaluate this, then we will be able to get the particular area that we need. I hope we are together, guys. So evaluating this, let's just come and do it. Integrate 7 minus x, we will have 7x. Minus integrating x, we will have x squared over 2. Limits from -3 to 2. Minus integrating x squared, we have x cubed over 3. Plus integrating 1, we have x. Limit is from -3 to 2. Then we evaluate this. You guys know how to replace the limits. So let's replace 2. Replacing 2, we have 7 into 2 minus 2 squared. That will be 4 over 2. Minus, replacing -3, we will have 7 into -3 minus -3 squared. And -3 squared will be 9. So 9 over 2. That is for this first bracket. and then minus, we are now on this side. Replacing 2, we will have 2 cubed over 3. 2 cubed is basically 8, plus 2. Minus, now replacing with minus 3, we will have minus 3 cubed, minus 3 cubed over 3, plus minus 3. If you evaluate all this in your calculator, you will get the area shaded, the area that was required. And evaluating that using my calculator, the answer is 25 over 6 square units. Square units. So let's do this question together, and then let's see how, if we are going to be able to get the answer, so that we see if we are on the same page. So 3. Sketch the curves. Sketch the curves. Y is equal to x squared plus 3, and y is equal to 7 minus 3x, and determine the area enclosed by them. And determine the area enclosed by them. So let's do this.